Welcome to clickmyproject.com. Our project title is Joint Spectrum Sensing and Resource Allocation Scheme in Cognitive Radio Networks with Spectrum Sensing Data Falsification Attack. Abstract. Spectrum sensing and spectrum sharing are two fundamental issues in a cognitive radio networks. The spectrum sensing data falsification attack imposes bad effects on both spectrum sensing and spectrum sharing. To deal with SSDF attacks and to instantiate secondary users to behave well, a joint spectrum sensing and resource allocation, that is JSSRA scheme in a cognitive radio network is proposed. The JSSRA problem is formulated as a weighted proportional fairness based resource allocation optimization problem under the constraint that the primary user network is sufficiently protected. The problem is decomposed into two subproblems, namely the resource allocation subproblems and cooperative SU number decision subproblems, which are solved by Lagrange's dual algorithm and the brute force algorithm. Moreover, a user selection method based on reinforcement learning is presented to select reliable SUs for cooperative spectrum sensing. In addition, the SU's trust degree is updated according to its behavior in CSS and is used in the sensed resource allocation process. The key point of our proposed scheme is to make SUs improve the sensing reliability and prevent the SUs from behaving maliciously by an intensive mechanism. Comprehensive performance evaluation is conducted by computer simulation. The proposed JSSRA scheme deals with the SSDF attack well in cooperative spectrum sensing scheme to improve system robustness and achieves a significant system utility gain in resource allocation. Let us see the flow of our project. In our project, we have to implement cognitive radio network and then we have to form attacker model. So we have to identify SSDF attack, that is spectrum sensing data falsification attack. For identifying these attacks, these attacks are formed in secondary users. For identifying these attacks, we use JSSRA optimization problem, that is joint spectrum sensing and resource allocation problem. So from using this, the CR node which searches the spectrum, if the primary user is sensing the spectrum, means it will be allocated to the primary user, else the freed unoccupied spectrum is allocated to the secondary user. Now the secondary user's trust degree calculation is done. So now the secondary user have any behavioral changes in their reporting from the trust degree, it will be identified as SDDF, that is SDF attack, and it is blocked from the network, else it is reported from BS and it sends the successful data transmission to the sync node and the performance evaluation is done. Let us see the output of our project. For running our project, we have to open VMware Workstation. In that, click on this terminal window. In that, we have to go to that coding folder. So type cd space our product and cd space that code folder. Then this is the syntax for running our TCL file. There is ns space main.tcl. So when we put this in terminal window, it will show all the trust degree implementation. So our process is to identify the attacker in a cognitive radio network. So we have to identify the sensing data falsification attack, which imposes the both spectrum sensing and spectrum sharing. This trusted degree implementation is implemented for identifying the attacker nodes. There is placed in secondary user SU. So for identifying these attackers, we have implemented JSSRA problem, that is Joint Spectrum Sensing Resource and Resource Allocation Scheme. So this resource allocation subproblem on the cooperative SU member decision subproblem, which are solved by using rectangular UL algorithm and brute force algorithm. So now trust degree implementation, that is the node which have abnormal leaving transmission power high, all the informations are displayed here. When it finished, it will display one window called NAM window. So now it's in 16 seconds. It will finish at 20 seconds. So now it is in 17 seconds. So this will shows all the information about the nodes, that is abnormal leaving, transmission power high, low, higher bandwidth. So these updated information with updated time shows the secondary user which have SSDF attack. It will show for all the nodes. So now the output window is opened, which is called the NAM window. So when we click on this pay forward button, it will works. So we have to increase the speed. So now this is our cognitive radio network, which contains number of primary users, secondary users and base stations. So for zooming the process, click this zoom button, and now this node 8 and 0 are act as a base station, and all the other nodes are act as a primary user as well as secondary users. So click on this play forward button. So now all the nodes, that is first the primary user which wants the information from the base station is collected the packet information from the base station. So these are all done by using JSSRA problem. So JSSRA problem sensing the spectrums. So this JSSRA problem sensing the spectrum by using spectrum sensing scheme, that is our the purpose of spectrum sensing is to access unoccupied licensed spectrum band assigned by the PU networks. So when the PU networks are free, then the secondary user nodes, that is SU nodes are get the information from the base station, this node of 8 base station. So now the node of 6 primary user get the information from the base station. Now the attacker is happen and it will drop all the packets. So when we click on this, each drop it will shows that dropped packet. So this is called as attacker. So the attacker which drop all the packets which is received from base station. So now all the primary users are get the information from the base station. So now it's a time for getting the information from the base station to the secondary user. So now attacker model is happen when the time of 15 seconds, the node 9. So now the node 9 gets the information from the base station which is unoccupied by the primary user. For running our graph file, type xgraph space thr.xg. So this is for running the performance, so for identifying the performance evaluation of the project. So this is the throughput graph. So we have achieved this much of throughput in our project. Thanks for watching.